Okay, so sorry, this one is the. Okay, so let's learn about the definition or what is electrochemistry is all about. So basically, based on the two types of energy, so we have the electrical energy and we have the chemical energy. Okay, so the study of relationship between these two kind of energy, so we call it as the electrochemistry. Okay, so the relationship between chemical reactions and electricity, okay, or the study between these two of energy, right? Science studying the relation between chemical energy and electrical energy, okay, as mentioned, is also the study of solutions of electrolytes and of phenomena occurring at electrodes immersed in these solutions, okay. So if we have the electrolytes, for example, and electrodes, okay, in electrodes, the electrodes and the phenomena occurring, okay, the oxidations, reductions, and the electrodes immersed in these solutions, we call it as the electrochemistry, right? So basically, there are two basic types of electrochemical cells. We have a galvanic cell and electrolytic cell, okay, or sometimes we call it as a voltaic cell, okay, and galvanic cell, and another type is electrolytic cell. So a voltaic cell or a galvanic cell can power electrolytic cell. Okay, so galvanic cell ni dia produce electrical energy, while the electrolytic cell ni it gain electricity to produce chemical reactions. Okay, while the galvanic cell it has chemical reactions that produce electricity. So may I what is the chemical reactions? So anyone can, what kind of chemical reactions? Anyone?
Redox reaction.
Yes. Who's that? Arif. Please say okay. So yes, correct. So the answer is redox reaction. It's written here. Okay. So the chemical reactions involved is the redox reaction, reduction, oxidation, which generates electricity. Okay. So this is we call as the galvanic cell, and the one that receive the electricity to induce the redox reactions is the electrolytic cell. Okay, so I believe you have learned all of this during your matriculation or in your schools. Okay, so we have the two terms of the chemical reactions involved in this electrochemistry. Redox reaction, we have the oxidations. So when we say about oxidation, it always loss of electrons. Okay, just remember this. So when we say about oxidation, it means loss of electrons. So this loss of electrons, it undergo oxidation process. Okay, as well as increase in oxidation number. And what is oxidized is reducing agent. Okay, and then the reduction is the other way around. It gain electrons. Okay, whenever the elements or atoms gain electrons, so we call it, it undergoes a reduction process. It reduce. Okay, just remember this. Okay, as well as it decrease in oxidation number. Okay, so what is reduced? So oxidizing agent. Sorry. For example, we have these reactions. Zinc, we put it in the acid, for example, ACl, where it consists of hydrogen plus ion. Okay, so zinc with zero oxidation number. So hydrogen plus plus one oxidation number. All right. So what happened here? Zinc, it lose two electrons. Okay, so it lose 2 electrons. When it lose 2 electrons, we call it as the oxidation. Okay, oxidation. So the oxidation number of the zinc increase by 2. All right. The other way is the H gain electrons. It gains electrons, so it reduce. Okay, so it reduce. So the oxidation number reduced to 0. So this is basically the redox reaction. Okay. So now we are going to look into how do we balance the redox reaction. Okay, so we have a method we call as the half reaction method. Okay, method is the half reaction method. So we can use this method to balance the any redox reactions. Okay, so the first is it involves the treating the oxidation and reduction as two separate process. Okay, so kita asingkan, kita ada oxidation and reduction, we separate them for each process, and then we balance each of these half reaction. So bila kita dah separate, dia akan jadi half lah, half kita balance, and then we combine them to attain the balance equation for the reaction. Okay, so we shall see how. So number one, what we can do is we assign oxidation numbers to determine what is oxidized and what is reduced. Okay, so senang bila kita tahu yang mana oxidize, yang mana reduce, then we can complete the reactions with sama ada dia lose electrons ataupun dia gain electrons. So kalau dia oxidize, so kita akan write the reaction as it lose electrons. Kalau dia reduce, dia akan receive electrons kan. So kita tahulah, kita boleh estimate lah. Tapi in this case, kita tengok macam mana kita akan buat dia punya ni lah nanti. Okay, macam nak balance. How do we balance this? Okay, in fact kalau the first step ni we can skip. Kalau kita dah identify lah, kita dah tahu kan, we assume. Tapi untuk selamat, just check the oxidation number to make sure that which one oxidized, which one is reduced. Okay, and then we write the half reactions, oxidation and reduction in a separate equation. And then in number 3, we balance each half reactions. So how do we balance them? So number 1, we balance elements other than hydrogen and oxygen. Okay, because the oxygens impart the addition of H, O imparts the addition of H2O. So kalau you buat yang ni dulu, nanti dia akan effect dalam you punya ni lah, balancing tu nanti kan. So the first step should be other element dulu. Okay, mesti ada element H dan oxygen. Okay, and then baru kita balance by oxygens. Kalau ada oxygens, kita balance with addition of H2O. H, we balance by the adding of H+. And then finally, we balance charge by adding electrons. Okay, yang ni kita nak balance the keyword here is balance. Kita nak balance. Kalau sebelah kiri ada oksigen, belah kanan tak ada oksigen. Macam mana kita nak buat? So kita tambah H2O. Kalau belah kanan ada H, belah kiri tak ada. So kita tambah H+ dekat kiri. And then we check both sides. Cukup tak dia punya electrons? Kan? Kalau sebelah ada negatif, sebelah tak ada. So we can add electrons. So belah kiri ada negative charge. So belah kanan kita kena balance kan. So the keyword here is balance. Alright. So number 4, we multiply the half reactions by integers so that the electrons gain and loss are the same. Okay, ini kita nak balance lah. So before we combine, we make sure that the electrons tu adalah balance. Sebab dia redox reaction, dia involve the movement of electrons kan. Elektron yang bergerak ni oxidize and mesti ada yang receive kan. Mesti ada yang receive. Okay. So kalau tak balance, so maksudnya tak complete lah. Kalau 2 yang lose, maksudnya yang receive pun adalah 2 electrons. Okay. So it is important that you make sure that the same lah. Kalau same, you don't have to multiply them. Kalau dia tak sama, you need to multiply so that they get the same integers. Okay. So and then add both half reactions, subtracting things that appear on both sides. Okay, ataupun you balance. Kalau ada dua-dua ni, you balance and enjoy your equation. Okay, so let's look at the first example here. We have MnO4 and a C2O4 oxalate 2 minus. Okay. Okay, so as you can see here, so we have manganese and the oxalate produce Mn2 plus and carbon dioxide. Okay, so from here, can you guess which one oxidize, which one reduce? Okay, so remember the first step is to identify. So first you identify which one yang oxidize, which one yang reduce. So from this equation, which one oxidize and which one is reduced?
Manganese oxidized.
Okay, good. So if the manganese oxidized, it means that the oxalate reduce. Okay, so good. So you can check lah, betul ke tak betul kan? Macam mana? Yes. Okay, so in first step, okay, we assign the oxidation number. So tadi siapa tadi? So mana bukan? Maksudnya manganese, maksudnya you tak check lah kan? Tadi you tadi ke you kata manganese reduce ke oxidize?
Oxidized.
Okay, so kalau you tengok dekat sini, the manganese it goes from 7 plus to 2 plus. Maksudnya dia reduce. Okay, so kita inilah. So it means that the important of the first step ni penting. Okay, so remember that. So you don't have to assume. If you don't know, then you can try to find the oxidation numbers here. Okay, so remember kan macam mana nak cari oxidation number. Here for example for this compounds, we have the oxidation number of -1 kan. So manganese plus 4, oxygen berapa? 2 minus kan, then -1. So dia akan jadi berapa? Mn -8 equal to -1. So Mn is equals to -1 plus 8, so it will be 7. Okay, so baru you check lah. So same goes to C2O4 ni. So it's equal to 2 minus 2, sorry. 2C plus 8 minus juga kan. 8 minus. Okay, -8 bawa ke sana, so akan jadi 6. 6 divide by 2, so akan jadi plus 3. Okay, so betul lah. So you need to check. Okay, so you need to check. So each of the oxidation number, so that you know yang mana reduce, yang mana oxidize. Kalau dia increase, dia oxidize. So in this case, the manganese is reduced and the oxalate is oxidized. Okay. Okay, so we divide them. So step number 2, we divide the reaction into half reactions. Okay. And then we balance each half reaction. Step 1 dulu. Okay. So to balance the carbon, we add a coefficient of 2. Okay. Sebab apa? Sebab we balance element other than oxygen and hydrogen. So in this case is the carbon, kan? So carbon. So carbon kat sini dia tak balance. Sini ada 2, sini ada 1. So we multiply by 2 for this, and then kita akan dapat balance in carbon. So bila kita letak 2 kat sini, oksigen pun dia akan darab jugalah, jadi 4. So coincidentally in this case it balance. Okay, dia dah automatically balance kan. When we multiply by 2, the oxygen as well balance. Okay, dia sama. Sini ada 4. At the left side pun ada 4. So good. So alright, and then we look at the hydrogen tak ada. So you don't have to balance the hydrogens. You don't have hydrogen here. So to balance the charge, kita nak balance charge. Okay. At the left side, we have -2. Okay. At the right side, we have 0. So macam ni kita nak balance? We add 2 electrons. Oh, ada kat bawah ni. Okay. So kat bawah ni. Okay. So kita balance by adding 2 electrons. So now for each side, left side pun ada -2. So left side pun -2. So you dah balance this half equation. Okay. And then we do the same thing for the another half reaction, which is the manganese. Okay. So first element other than oxygens and hydrogens. Okay. So we have manganese. Memang dah sama lah satu-satu. So you don't have to multiply with any numbers for the manganese. Alright, and then the oxygens. So at the left side we have 4 oxygen. And then how we balance them? We put 4 H2O. So remember the step. So to balance the oxygen is oxygens H2O. If the hydrogens, we put the H plus to balance. Okay, remember this. Okay, ingat je ni. So H2O, 4 H2O. So akan dapat 4O. Left side pun 4O. So now if you can see here, kita akan ada H. So that's why kita kena balance oxygen dulu baru hydrogens. Okay, if you see the step tadi, kita balance oxygen dulu baru hydrogen. Kenapa? Sebab bila kita balance oxygen nanti dia ada penambahan H kat sini. And then baru kita balance with the hydrogen. Okay. So you need to follow this step. Alright. So now hydrogen. So we balance the hydrogens. As you can see here, we have 8 hydrogens. 4 times 2. Okay, sorry. So we have 4 times 2. So it's 8 H plus at the left side. Okay, kita tambah 8 H plus to balance at the right side. Okay, kita ada 8 hydrogen. Okay, and then to balance the charge, okay, so we add electrons. So as you can see here, macam ni kita nak tengok electrons ni, you kena calculate, okay, for each left side and the right side. Berapa dia punya charge dia, okay. Okay, so berapa charge dia kat sini? Sini ada 8 plus and negative. So it means that we have positive 7. At the right side kita ada 2 plus. Betul? So dia tak balance kan charge dia. So macam ni kita nak balance? We add the 5 electrons kat sini so that dia akan minus 5 akan jadi 2. Faham eh? So kita put the 5 electrons here sebab electron adalah negative charge. So negatif dengan positif dia akan minus lah. 7 minus 5. So akan jadi berapa?
2.
2 kan. So kanan pun adalah 2 plus. So balance lah. So 2 plus and then 2 plus. So mana the charge tu dah balance. Right. So right. So we have the step 4. So tadi kita tak combine lagi. So yang ni macam-macam each half of the half reactions. And then we need to multiply the half reaction by integers so that the electrons gain and loss are the same. Okay. Kalau if you can see here, the first half reactions we only have 2 electrons. Okay. And the for another half reaction we have 5 electrons. So dia tak balance. So you tak boleh combine lagi. Sebab dia tak sama kan. Electrons yang loss tak sama dengan elektron yang gain. So dia kena samalah. Elektron yang oxidize, yang loss of electrons should be the same with the gain of electrons. So what we can do is we multiply, okay, multiply with the numbers so that you will receive the same value of redox or electrons lah kan, electron yang loss. And okay, so 5 we we can times by 5. Kita darab je lah kan. 5 we times 2. Ada kat sini dah. Okay, so remember when we multiply them, so you need to multiply all of them. So this one 5, this one 5. Jangan you multiply satu saja. You jangan multiply this one saja yang so you akan jadi salah. So if you multiply by 2, all should be multiplied by 2, including electrons, hydrogens, and the compounds here. Okay, so that you akan dapat ni lah each. So now you can see here, the electron is the same, sama kan, 10, 10. So bila dah sama, you can combine them. Okay, so you combine. Macam ni kita nak combine? Yang at the left side, at the left, yang right dekat right lah. Okay, you jangan pindah pula yang kanan ke kiri. Bila you combine plus, so kat sini ada kat left side, so put in the left side lah kan. Yang ni kat right side, put in all in the right side. Okay. Okay, and then subtract things that appear on both sides. Okay, ini bila dia ada kat sebelah right and left, so we can subtract them. Okay, so ini kita dah add, so kita boleh subtract the electrons, ada dua-dua belah. Okay, electrons, and then apa lagi? Tak ada dah kan? Tak ada dah. Okay, so sometimes ada yang H2O kan, ada yang H2O, so you need to subtract them. So then we get the balanced redox reactions. Okay, is everything clear so far?
Yes.
Okay. Okay, good. Right, and then we also have situations where reaction occurs in basic solutions. Okay. So tadi tu in ni acid, kalau if it occurs in the basic solutions, okay, kalau ada questions tu, the questions specifically mention about the reactions occurs in basic solutions, then the balancing of the equation we need to consider as in the basic solutions. Okay, the principle is exactly the same. Okay, cuma kita ada add the OH minus saja to each side to neutral the H plus. Okay, kalau you perasan tadi, sini ada H plus kan? Kan, ada 16 plus. Kalau the reaction occur in OH, you just tambah je OH on both sides. Okay, tadi tulis kan? To each sides, okay, 8 OH minus to each sides. So maknanya kat sini kalau ada H plus, maka you tambah 16 OH minus. Bila you tambah kat sini, jangan sebelah saja, belah-dua belah lah. Okay. 16 OH minus. Okay, clear? So bila H plus tambah dengan OH minus, dia akan jadi H2O. Okay, so akan jadi 16 H2O. Okay. At the right side, dia akan 16 OH minus lah. So dia akan jadi reaction yang berlaku dalam OH minus. Okay. Okay, so if this produce water on both sides, so kalau ada water in both sides, you might want to subtract water from each side. Tolak lah kalau ada sebelah dua-dua belah kan. Okay, so this is the example. So sama je lah. I think you can read this later on. Okay, you can try this question. Okay, sama je lah macam yang saya mention tadi kan. So boleh cancel out water and then you can dapat balance equation that consists of the OH minus. Okay. Okay, so again, this one highlight about the spontaneity. So you need to understand the voltaic cell, it involves a spontaneous redox reaction. Okay, so when we say about spontaneous, it consists delta G less than 0. Okay, so delta G is used to estimate the spontaneity of the reactions, kan? As you learn. So if the delta G is more than 0, it defines that it is a non-spontaneous reaction, as in the electrolytic cell. Okay, so electrolytic cell. Okay, so clear So voltaic cell ni dia spontaneous reaction, sebab dia ada chemicals tu, for example in the electrolytes tu yang memang dia akan spontaneously react. Okay, bila dia react through the redox reaction, dia akan produce electricity. While the electricity is the other way around. Kalau dia tak ada electricity, dia tak akan berlaku chemical reactions. Okay, so this is non-spontaneous. So electricity cell is non-spontaneous. Bila ada electrical energy, baru dia boleh drive a redox reaction. Okay, maksudnya it does not happen naturally. Kalau voltaic cell, dia naturally happens from the redox reaction tu lah. So dia ada A, for example A dengan B. Okay, so we have A and B. So in voltaic state, A ni dia memang nak menderma elektron. Dia memang nak menderma, B dia memang nak menerima. Okay, so kalau in electrolytic cell, A dengan B dia tak nak bagi. Okay, so A and B ni masing-masing tak nak buat apa-apa. Tak nak communicate, tak nak apa. Bila ada energy, baru dia nak bagi. Kita paksa dia bagi elektron. Okay, so this is the case for electrolytic cell.
Doktor,
Yes?
kalau delta G equal 0, voltaic ke electrolytic?
Delta G equal to 0.
Is it possible?
Sekejap, kalau tu dia apa, in delta G is equal to 0, maksudnya dia in equilibrium. Dia tak ada apa, tak ada ni lah, tak ada reaction, dia in equilibrium, if I'm not mistaken lah. Okay.
Okay.
Ke yang tu nanti saya check, nanti kita tengok ada tak case and delta G is equal to 0. Okay. Sebab dia ada juga case dan dalam bila di reaction ni sampai apa we call as the equilibrium, dia dah maksimum dah reaction dia tu kan. Nanti kita tengok, nanti adalah dia punya apa ni.
Okay, doctor, thank you.
Okay, so both type of cell are constructed using two electrodes. Okay, placed in electrolyte solution. So the anode, kita ada anode dengan cathode. So anode is where the oxidation is occurs, and the cathode is where is the reduction occurs. Ini tak berubah Kalau when we say about anode, it always oxidation. When we say about cathode, it always reduction. Dia tak berubah. Okay, yang ni ingat. Senang nak ingat lah. Kalau tahu anode, what happens anode? It always oxidation. Okay. Ini yang saya explain tadi lah. So we have the electrolytic cell, and also we have the voltaic cell. Okay, kita ada electricity from A to B, and electrolytic cell C to D, where it is not non-spontaneous. Okay, it is non-spontaneous. Bila kita paksa dia, kita letak bateri kat sini, baru ada chemical reaction. Dia terbalik. Kalau let's say chemical reaction to electricity, for the electrolytic cell is vice versa. Okay. Okay, ini samalah. For example, in this case is the voltaic cell. Okay, so we have the voltaic cell. It creates electricity using a chemical reaction. For example, we have a zinc and a copper here. Zinc always want to oxidize. Zinc always want to give electrons, and copper always want to receive the electrons from the zinc. So bila dia masing-masing bekerjasama ni, dia ada pergerakan elektron. Bila ada pergerakan elektron, ia akan ada electricity. Okay, so he defined these chemical reactions that create the electricity. Okay, ini pun sama. Right, so construction of a voltaic cell. So each half reaction takes place in own half cell, so that the reactions are physically separate. So each half cell consists of electrode in electrolyte solutions. Half cells are connected by this external circuit. Salt bridge completes the electrical circuits. Okay. Ini kalau kita ada ni lah, the construction of the cell ni macam mana. So kita ada zinc kat sini and then connected with the salt bridge. Okay. So zinc oxidize, produce zinc 2 plus ion, copper 2 plus, it receive the electrons, it form the copper solid. It means that kat sini dia akan ada pertambahan copper solid. Dia akan ni lah, dia akan, we call that, dia akan agglomerates kan, akan form precipitates. While zinc ni dia lost electron, dia oxidize and it becomes the ions. Bila ions dia akan dissolve in this aqueous solutions kan. So dia akan terhakis lah kat sini. So zinc akan terhakis. So copper dia akan bertambah. Okay. Okay, ini sama dia. The salt bridge completes the electrical cycle and allow ions flow through both half cell. So if zinc is oxidized, so zinc ions are formed and enter the solutions. So C2 plus leaves solution to be reduced at the cathode. So the salt bridge are responsible in maintaining the electrical neutrality by allowing excess zinc 2 plus ion to enter from the anode. Okay, and excess negative ions to enter from the cathode. Okay, so mana kalau dia terlalu excess ion, so salt bridge ni dia boleh maintain the electrical neutrality. And also the salt bridge ensure the complete of the circuit. Okay, completes the circuit kat sini, completes the electrical circuit. Okay, so yang ni flow dia lah, flow of charge dia. So zinc give the electrons to the copper, and then kita ada kat tengah ni lah salt bridge. Okay, okay, can ion move through the salt bridge from the anode solution to the cathode solution, and the other way around for anions. So by convention, a voltaic cell is shown with the anode on the left and the cathode on the right. Okay, so by convention we write them in this way. So kalau belah kiri tu maksud dia adalah anode dan belah kanan tu adalah cathode. It represents it reduce and oxidize. Okay, and then let's look on the electrodes. So we have the inactive electrodes. So active and inactive electrodes ni, it means that the electrodes that participates in the reactions. Okay, so active component in half cell and is a reactant or product in the overall reactions. Okay, so this is what it mean by the active electrodes. Maksudnya dia involve macam zinc dengan copper tadi. Okay, zinc tadi dia adalah electrodes dan dia participates dan dia active components in the overall reactions. While the inactive electrodes ni dia tak participate pun, cuma it provides surface. Okay, it provides surface for the reactions and complete the circuit. Okay. Alright, so inactive electrodes such as graphite or platinum. Okay. Okay, so this is the example of voltaic cell using inactive electrodes. Okay, we use graphite here. Okay, cuma yang participate adalah electrolyte lah. For example, in this case adalah iodide ion ni. Okay, kat sini kita ada manganese. Okay, dia hanya provide surface saja. Okay, and then notation for a voltaic cell. Kita ada juga notation, how we notation. The way is through by writing the anode components on the left, okay, macam tadi juga left, and the right is the cathode component. Okay, so the single line show a phase boundary between the components of the half cell. Okay, so kita ada solid dengan yang ni, and then kita ada copper ions and the copper solid. So the double line shows that the half cell are segregated. Okay, kita double line lah. You can imagine this like a salt bridge kan. So dia ada dua tu kan. You imagine lah separate dia macam ni. Alright. So if needed, concentration of dissolved components are given in parentheses. So if not stated, it's assumed that they are 1 molar. Okay, so mana penting if the questions ask about the notations, kalau the notation tu ada specific concentration, you need to write the concentration lah. For example, zinc 2 plus berapa, Cu2 plus berapa dia punya concentration lah. Bukan yang solid ni lah, yang ni so kalau tak ada, 1 molar. Tapi if the question is not 1 molar, then you will get the wrong answer for the notation. Okay. Okay, so this notation, so kalau if you use the inert electrode, okay, and sama jugalah, left side is the anode and the right side is the where is the reduction occur. Okay. Okay, so this is the equation. So you can look draw these equations, draw a diagram, show balance equations. It's number 2. So first kena draw. Number 2 is show balance equations. And number 3 is write the notation. Okay. Write the notation for what is said. It consists of one half cell. So half cell kita ada chromium bar in chromium nitrate solutions. Another half cell with silver bar in the silver nitrate solution. And CaNO3 sub-bridge. Measurement indicates that the chromium electrode is negative relative to the silver electrodes. Okay, so so this is the plan from the given contents. So we write the half reactions. Okay, to determine which is the anode compartment and which is the cathode. Okay, so we note that the relative electrode charges. Electrons are released into the anode during oxidation. So it has a negative charge. Since chromium is negative, it must be the anode and the silver is the cathode. Okay, so in this case lah, kita dah ada cathode dengan anode. So and then we balance the overall equation. Yang ni simple je lah kan. Dia tak ada oxygens and hydrogens. Simply balance them. So okay, ada 3 silver. Alright. So and then the cell notation, macam tadi, belah kiri ni adalah yang oxidized. So chromium is oxidized, which is the anode at the left side. So at the right side is the cathode, where the reduction occurs. Okay, ada lagi tak jawab soalan tu lah. Cell notation kan, balance and then draw. Okay, you kena draw lah. So in order to draw this, you need to understand lah. You need to understand yang mana anode, yang mana cathode. Okay, just very simple setup of the galvanic cell.
Doktor.
Yes?
Saya nak determine anode cathode tadi. Center chromium. Center chromium.
Kalau tengok sini, ni lah, indicate, dia dah bagi dah jawapan sebenarnya. Is negative relative to the silver electrode. Okay. Is negative. Okay. So bila dia negatif, dia ni lah, straightforward je ni equation dia ni kan. Macam nampak macam tricky kan. So yang ni
Negative relative maksudnya?
Maksudnya bila dia punya ni bila kan kita ada electrode, kan kita ada positif dengan negatif kan. Macam tu lah. Maksudnya dia straightforward je. Bila yang mana positif, yang mana negatif. Okay. So kalau galvanik, kalau yang ni you kena tengok kalau yang ni dia punya Dia negatif ni lah. You kena tengok dia sama ada dia galvanic ataupun dia ni. So kalau in this case dia adalah anode. Ni kan kalau tengok saya rasa ada dekat dalam first slide tadi kot. Let me check Kita tengok kat sini nampak tak? So, kita ada ni dia ni lah mana relatif dengan positif kan. So kalau sebab tu you kena tahu kalau di galvanic dia berbeza dengan electrolytic in term of ni lah negatif dengan positif ni. Okay, kalau positif dengan negatif. Tapi so remember that kalau anode always oxidation, nampak kat sini anode oxidation, cathode reduction. Cuma in term of the ni lah relatif dengan positif ni dia berbeza in terms of the galvanic cell ataupun electrolytic cell. Okay, faham dia straightforward je lah soalan dia. Maksudnya you kena tahu this one dulu negatif. Kalau nak senang kan macam mana tengok dia punya apa you assume as a battery. Okay, kalau battery you perasan tak dia ada dua belah kan. Okey kat sini lah. Okay, nampak tak battery kan? Okay, so dia ada positif dengan negatif kan, betul tak? So kalau bateri ni it is a galvanic cell kan. So kita ada negatif dan kita ada positif. Macam itulah. Tapi kalau electrolytic cell yang mana connected dengan positif tu dia adalah inilah dia akan jadi positif, yang mana connect dengan cathode tu dia akan jadi negatif. Okay. Mana tadi? Okay. Okay, nampak? So, yang ni adalah voltage cell ataupun galvanic cell kan. So, dia kata C is negative. So, kalau negatif maksudnya oxidation lah, ada anode lah kan. Kalau you tengok dekat yang tadi tu kan. So, dia adalah straightforward je. Okay.
Okay.
Mana saya nak tolong awak bagi saya ingat Kalau saya guna bateri, konsep bateri tadi. Okay lah, tak apa nanti you tengok balik. Okay, and then let's look on the yang ni dah sebelum ni. Okay, kita tengok on the electrical potential. Okay. So when the switch is closed and no reaction is occurring, each half cell is in equilibrium state. Okay. So zinc is a stronger reducing agent than a copper. So the position of the zinc equilibrium lies farther to the right. And zinc has higher electrical potential than copper. So when the switch is closed, electron flow from zinc to copper to equalize the difference in electrical potentials. So the spontaneous reaction occurs as a result of the different abilities of these metals to give up their electrons. I think this one better to look at the table nantilah kita akan tengok lagi macam mana we identify them as which one yang lebih have a tendency to reduce. Okay, the cell potential. Yang ni tadilah kan explain tadi. So the cell potential of a voltage cell depends on the difference in electrical potential. Okay, so bila ada electrical potential difference between the two electrodes, so baru dia akan ada cell potential. Okay, nanti kita tengok dalam table nanti. I think much easier to look at the table nanti. So the cell potential also called the voltage of the cell or the electric force. Okay, so ada kita panggil EMF ataupun kita panggil cell potential ataupun kita panggil voltage. Semua it is equivalent or represent the same meaning. So kalau E cell is more than 0, so maknanya dia adalah a spontaneous reaction. Dia terbalik dengan delta G tadi kan. So, kalau delta G is less than 0, okay, less than 0, so maksudnya dia adalah spontaneous reaction. Tapi it's the other way around for the potential. Potential dia kena positif lah, kalau tidak dia tak produce lah electricity kan. So bila dia produce electricity, maksudnya dia ada voltage, dia ada potential. So E cell dia should be more than 0. Okay, so kalau for electric cell, ni lah, it's the other way around. Okay. So this voltage of some of the voltage cell, battery kan, ada voltage tertentu. So all it depends on the potential kan, electric potential between the metals kan, antara dua metals tu, lagi jauh jarak dia, lagi kuatlah bateri dia. Okay. Okay, lagi jarak, beza dia punya electric potential satu sangat jauh. Kalau dia dekat, dia punya potential tu antara two metals tu, maksudnya dia akan produce very low voltage lah sikit. So kalau jauh dia punya potential dia akan ni lah. Kita tengok table nanti. Okay, and then measuring the standard potential of zinc copper cell. So kalau tadi E cell tadi adalah voltage yang produce lah antara dua ni. And then kita ada juga the term that we use as the standard cell potential. Okay, we write it as the E node cell. Okay, E node cell. So E node cell ni maksudnya dia by default ataupun the standard potential tu yang berlaku antara dua metal, for example, under the standard conditions. What are the standard conditions? Dia adalah ni lah, 1 molar concentrations under 1 atmosphere pressure yang semua condition ni yang dia carry out. Nanti kita tengoklah dia punya standard, macam mana, how do we measure the standard. Okay, temperature 25 degrees Celsius. Okay, all components are in their standard states. Okay. So the standard electropotential half cell is the potential of a given half shape when all components are in their standard states. Okay. Alright. Okay. So by convention, all standard electropotential refer to the half fraction written as a reduction. Okay, so the standard cell depends on the difference, and like as mentioned earlier, the difference between the abilities of the two electrodes to act as a reducing agents. Okay, so this is the formula. So E node cell, okay, E node cell is equal to E node cathode minus E node anode. So this is always the formula. Okay. Okay, nanti kita tengok dia punya contoh dia. So if half cell potential are measured relative to a standard half cell, so dia okay, so macam ni, macam mana dia nak calculate the half cell potential. Okay, so mana kita ada setiap satu ni, E node cathode ni dengan E node anode ni, dia ada relative to the standard ni lah hydrogen electrode. Okay, sebab dia kosong. Okay, bila dia kosong, kita akan dapat value for each ni lah metal kan, anode ataupun cathode. So bila kita tolak this the difference, tolak ni sebab difference tadi tu kan yang saya lukis tu. So the difference between this, jarak dia ni adalah bersamaan dengan E cell. Okay, so kalau ni adalah under the standard state, we can straightforward use this equation, E cathode minus E node anode. Okay, so each of ni dia ada standard dia. Okay, macam mana value adalah based on the standard hydrogen electrode. Sebab the standard hydrogen electrode is 0. So dia akan jadi reference. So kita akan dapat value for each electrode tu lah ataupun metal. So this standard electrode consists of a platinum electrodes. So platinum electrode tak participate kan, dia inactive with the hydrogen gas, so hydrogen at 1 atmosphere bubbling through it and it immersed in 1 molar of strong acid. Okay, pakai 1 molar. So this is the standard state lah. So when we calculate it has a zero lah, dia akan zero potential. So bila combine antara dua ni, for example, ada tak contoh? Okay, this zinc. When we set up between zinc and the standard hydrogen punya ni, half ni, so bini adalah kosong. So kita akan dapat the value for zinc only. Okay, bila dia baca 0.76. Okay, so maknanya dekat sini tadi, kita akan dapatlah value for zinc kan, for example 0.76. So dia ada value dia masing-masing. So kita boleh straightforward calculate the difference between the potential. Okay, so zinc lose electrons, ini receive. Okay, let's look at this problem here. So a voltaic cell houses the reaction between aqueous bromine and a zinc metal. Okay, aqueous bromine and zinc metal. So the question, mana question dia? Here, calculate E bromine. So calculate and given that E zinc is equal to negative 0.76. Okay. So kalau kat sini you tengok apa information yang dia ada, kita ada E not cell. E not cell maksudnya the difference between bromine dengan zinc lah. Zinc dia diberi, cuma dia suruh kita calculate di E not bromine. Okay, so E not cell is positive, so the reaction is spontaneous. Okay, so by dividing the reaction into half reactions, we see that the bromine is reduced and zinc is oxidized. So thus, zinc half cell contains the anode. So we can use the equation for E not cell to calculate bromine. Okay, kat sini you nampak tak? Sebenarnya dia nak identify mana anode dan cathode. So bila you dah identify, you can use formula. Apa formula dia? E cell is equals to
E cathode minus E minus
E cathode minus E anode. Kena ni. So bila you dah identify mana cathode, mana anode, then you can simply use this formula. Alright. So kita tengoklah dia dah buat, dia tulis lah. So dia dah tahu dah mana cathode, mana anode. Zinc kita dah tahu value dia. Okay, kalau zinc dia adalah anode kat sini lah kita dah tahu value. E cell pun kita tahu. So kita can straightforward calculate dia E cathode. Okay. So E cell 1.83. E bromine kita tak tahu. Minus negative 0.76. So mana positif akan bawa sana akan jadi negatif. Tolak dia akan jadi inilah. Yang akan dapat E bromine. So Tara dapat, you can get the answer. So far clear this regarding this equation? Ada yang tak clear tak?
So far clear, Doctor.
Okay, good. Okay, so now let's look at the standard electrode potential yang saya mention tadi lah. Okay, so untuk kita measure lah yang mana has a tendency to reduce more than the others. Okay, so E values reflect the ability of the reactant to act as the oxidizing agent. Or in other words, bila the oxidizing agent maksud dia apa? Dia reduce. Kalau saya personally saya suka refer in terms of the reduction. Okay. Kalau you have a problem lah, mana agent macam agent apa pula ni kan. So you can straight away focus on the reduction lah. Okay. So mana the value of the E naught tu, kalau dia tinggi, maksudnya dia adalah has a high tendency to reduce. Faham maksud dia positif. Kalau ada positif, negatif, mana lebih tinggi? Positif lah kan. Kalau ada yang lebih tinggi daripada ni, maksud dia lebih nak reduce, dia lebih nak menerima electrons. Okay. Kalau in this way it write as the oxidizing agent is okay. Kalau you nak refer as this one pun okay. Cuma saya personally I like to use the term reduce. Yang mana lebih suka reduce. Okay. Yang mana sebab oxidizing agent takut you confuse dengan oxidize ke apa kan. So straightforward use the reduction. Mana more negative will act as the will reduce lah more readily reduce. Okay. Okay, as you can see here, kita nampak dia punya strength dia kan. So bila dia lagi positif, dia akan lebih tendency to reduce. Sebab tu kita panggil standard electron, ataupun sometimes we coin as standard reduction potential. Standard reduction potential. Maksud lagi tinggi E value, dia lagi tend to reduce. Okay, for example lah, saya ambil dua value kat sini kan. This one dengan sini. Mana lagi tinggi? Yang ni kan. So bila you put this together, yang mana akan reduce?
Manganese.
Yes, correct. So senang lah, as simple as that. Okay, as simple as that. So kalau you nampak ada dua beza, mana lagi tinggi? Ataupun negatif, you tengok kalau ini negatif dengan negatif here, mana lagi tinggi value dia? Sometimes confused dengan negatif kan. Is one kan. Walaupun negatif tapi the less negatif maknanya dia lebih higher lah. Maksud this one dia akan tendency to reduce. This one yang akan reduce. Okay. So make sure you understand this very well. Okay. Ini adalah standard reduction potential lah. Various ni. So remember yang ni semua has been experimented. Semua dah tested lah against the hydrogen tadi tu yang kosong kan. So bila kosong yang ni represent this particular half reaction lah. Okay. Ini apa pula ni? Each half fraction contains both. Yeah, I think yang ni sama je lah yang tadi kan. Sama je tadi. Yang ni lebih kepada nak explain lah yang mana sama according to the table dan juga value tadi. Okay, so kalau you dah ada value dia tu, so you can you may know which one yang cathode, which one yang anode, which one yang reduce, which one yang oxidize. So from that kita akan dapat cell. So remember these tables tadi, yang ni adalah under standard So under standard. So mana question yang kita use adalah question E node cell minus A is equal to E node cathode minus E node anode. So ini kena you remember lah. Kalau di standard we need to use this formula. Kalau non standard kita kena guna different equations. This one pun sama juga. Okay. Alright, so for the for this one, okay, for this one is not for non-spontaneous. Of course, saya tadi for the spontaneous reactions. Sorry, for standard dengan non-standard lah. Okay, kita tengok dulu So for spontaneous redox reactions, delta G is less than 0. So E node cell is more than 0. So we have learned this. And then we have a formula. Okay, formula we can calculate to calculate the E node cell under the standard conditions. So kita ada ni lah 3 equation. Delta G is equal to N times Faraday constants, which is given here, times JE times the E cell. So you can find the delta G lah. Okay, so kalau you tahu E cell, so kalau ada soalan tu nanti, so find the delta G, so we can use this equation. But this is under the standard conditions. Okay. Ataupun here, you can see here, E naught cell is equals to R times T. R is the gas constant. Temperature divided by Faraday constants, you akan dapat N. Or E naught cell is equals to 0.0592 divided by log K. This value actually coming from here lah. Kalau you times kan, constant times the temperature under the standard conditions divided by Faraday constants, log change to ln, ln change to log. So kalau you calculate, you akan dapat lah same value. So it's actually the same thing here. Sorry. And then the interrelationship, interrelationship ni tadi juga apa kaitan dia? So delta G kait dengan K adalah through this equation. Delta G with the E naught cell through this equation. And E naught cell with the K is through this equation. Okay, so yang ni sama tak macam tadi? Siapa tanya tadi? Ami ya? Ami tanya tadi kan? So kalau delta G kosong, maksudnya dia adalah at equilibrium. Okay? Do it at equilibrium. Okay, let's try this problem here. Let's have a look. So lead can displace silver from solution, and silver occurs in trace amounts in some ores of lead. Given the equation here, lead plus silver ion produce a lead ion and a silver solid. Okay. So as a consequence, silver is a valuable byproduct in the industrial extraction of lead from. So, kejap kita rest sekejap lah. 5 minit boleh?
Okey doktor, boleh?
Okay, dah.
Okay, shall we continue?
Yes, Doctor.
Okay. Looking at the attendance here, I think ada seorang lagi yang Azra Auni ni kan, tak ni. So Azra ada ke? Azra Auni, are you here? So please make sure lah, takut ke dia tak datang.
I'm here, doctor. Sorry.
Okay. So, alright, okay, it's okay. So yang lain macam mana, bila ada plan yang bila nak return to campus ke macam mana, ada planning tak? The rest of the students lah yang mana tak ada kat campus. Ada cohort planning returning student campus macam mana? Ke semua tak nak balik ni? Hello? Amir, saya tahulah Amir ada kat sini kan. Yang lain-lain macam mana? Ada plan tak untuk return to campus ke macam mana? Semua dah vaksin kan? Azra pun ada kan, if not mistaken?
Yeah, I'm on campus, doctor.
Oh, dah ada kat sini.
Ada.
Okay, so my question is to the rest lah, yang lain-lain kan. Arina ada ke?
Ada.
Ada dekat campus okay, cuma I'm not sure ke semua dah ada ni.
12 orang. Ada 12 orang je kat kampus.
Okay, I mean yang lain tu, yang tak ada tu, ada tak planning bila ke nak return ke macam mana ke? So I'm not sure lah macam mana planning from the university management dia kan. Ada task force dia kan. Yang lain macam mana? Siapa yang tak ada kat sini? Cuba, can you raise your hand? Raise, tekan klik yang ni. Can you raise your hand? Akira. Okay, Aisyah, Fitri, Zulaika. So Syuhada bukan dah ada ke hari tu?
Yang ini punya saya tunggu arahan you kalau suruh balik ke doktor.
Oh, tapi hari tu ada kan?
Ada.
Oh, dah balik lah. Awak balik-balik Okay. Ni macam mana yang lain-lain? Macam mana si Zulaika, Anis, Syuhada, Farhana ni? Macam mana? Tunggu arahan universiti juga ke macam mana?
Betul kan?
Ada ke arahan dari universiti? Bukan dah ada ke? Bukan dah suruh balik ke? Ke dia ada schedule dia? Dia ada returning schedule dia? Oh, not sure. Yes, Akira. You say something?
Sekarang ni kan boleh pilih nak pergi sana ke atau tak.
Oh, boleh pilih.
Uh,
Oh, okay. So you pilih not to ni lah, return lah.
yes.
Syahira, Siti Syahira. Siti Syahira, are you there? No. If you have the opportunity lah, kalau you ada peluang balik sebenarnya it's better lah kan, you join, baru you dapat feel lah kan. I think you belum lagi kan since you the first semester lagi kan. So if you have the opportunity, baliklah baru you dapat feel kan macam mana dengan kawan-kawan nak jalan-jalan kat Kuantan. Okay, so alright, kita sambung sikit lagi. So kita sambung. So tadi sampai mana Yang ni ini dah belum. Okay, ini belum. Okay, let's look at this problem. So lead can display silver from bukan tadi soalan yang tadi ke dah tadi? Allah, mana?
Yang belum. Betul.
Yang ni lah dia, betul lah dia. Yang ni lah dia.
Yang ni.
The spontaneous reduction into the half fractions and use values from appendix D to calculate the E naught cell. From this we can find K and delta G. So question dia back to the questions lah. So kita tengok question di sini. So nak cari K, nak cari delta G and then E naught cell. Okay, macam mana nak cari? So by using the equation dia. Equation yang diberi tadi lah. So masing-masing ni. So first writing the half fractions with their E naught values. So yang ni you faham kan, kalau according to the table tadi masing-masing dia ada half fractions dia. The reaction always receive electrons sebab dia based on reduction potential kan. E naught is represent the standard reduction potential. So remember standard ataupun standard atomic potential, tapi kalau ni standard reduction potential. Okay. So dia ada E naught value dia masing-masing. Kat sini antara dua ni mana satu yang akan reduce very quickly? Part
Argentum.
Yes, correct. So you faham lah. So please remember this. E naught tu kalau dia lebih more positif, maksudnya dia yang akan reduce compared to other one. Ini negatif lagi lah kan. Negatif. So and then kita dah ada E values. So ini kita reverse. Okay, sebab dia adalah dia nak completekan reaction kan. Bila satu loss of electron, satu adalah receive electrons. Betul so yang ni dia terbalikkan. Walaupun dia terbalikkan, dia punya E value dia adalah sebab yang ni adalah represent reduction potential. So we use this value lah, negative 0.13 dengan 0.8 for the argentum. Okay, so we complete the reaction, combine, and then the E cell is equals to E naught cathode minus E naught anode. So E cathode is 0.8 minus negative 0.13, so you can get the E naught cell which is equal to 0.93. So satu soalan siap lah kan? Yelah kan, dia dapat lah kan. Okay, so satu dapat E naught cell. Sekarang ni kita nak cari K pula. Okay, so K by using this relation tadi lah. Tadi kan kalau you tengok yang ni, so dia ada masing-masing kan. Kalau you dah ada E naught cell, nak cari K, kita guna yang ni. Okay. So yang ni dia ada tricky sikit, if I'm not mistaken, sebab dia ada tak ada bukan. Okay, so dia pakai straightforward yang ni lah equation. Yang ni senang. So whenever yang ni K, terus guna ni lah. Kalau yang ni kan, terus yang ni sebab dia dah simplify kan, dia dah time. Tak perlu kira kan Faraday gas constant dengan temperature ni. Kalau the temperature is 298 lah, understand it. Okay, 0.0592 divided by 2. 2 is the number of electrons. Okay, so kat sini tengok number of electrons is 2. Yang ni kadang ni lah. So 2 log K is equal to 0.93 kat sini kan. Masuk kat sini tadi. Kat sini. Okay. 0.93. So from here you can find the K lah. K log K bersamaan dengan 0.93 divided by inilah darat silangan, ni darat 2. Ni 0.93 divided by 0.952. You akan dapat the value for log K. So ini log K. So kalau nak cari K macam mana? Ni log, ni maksudnya 10 kan. So ni K bersamaan dengan 10 to the power of 31 kan. Betul tak? Cuba kira, betul tak? Betul So and then setelah K dapat, and then the value of G pula, delta G, using this formula, so you akan dapat negative 2 mole times the Faraday constant, usually diberilah 96.5 ni, kilojoule per mole per volt ni, times the E naught cell 0.93, so you akan dapat delta G. So you can get the relation from these equations. Okay. Okay, and then about the Nernst equations. So Nernst equations used to calculate the E cell if is not under the standard potential. Kalau tadi kan E cell ni under the standard ni kan. So kalau the reaction to undergo under non-standard, maksudnya kita kena pakai Nernst equation. Dia ada pembetulan sikit lah. It means that dia ada kiraan tu berbeza berbanding dengan standard. So yang ni adalah standard. So sama ada dia lebih tinggi ataupun lebih rendah. Okay. So dia bergantung kepada this equation lah, this which is Nernst equations. Okay. So kalau kita ada Q less than 1, Q kat sini mana product over reactant So product over reactant. So, product over reactant. So kalau reactant dia lebih banyak, so it means that Q akan less than 1. So bila this value Q is less than 1, dia akan menyebabkan E cell lebih tinggi daripada E node cell. Okay, macam saya mention tadi kan, sama ada lebih tinggi atau lebih rendah kan, bergantung kepada this equation kan, betul tak? Sama ada lebih tinggi atau lebih rendah berbanding standard dia. So kalau reactant dia lebih tinggi, so E cell dia akan lebih tinggi berbanding dengan E node cell. Okay, kenapa? Sebab dia ada banyak reactant. Reactant banyak lagi untuk buat chemical reaction. Redox reaction tu lebih banyak berbanding standard dia. Standard dia, for example ni ada standard dia this kind of value. Tapi in this case, reactant dia lebih banyak. So bila lebih banyak, akan lebih banyak redox reaction yang akan berlaku. So dia akan lebih tinggi daripada sepatutnya. Okay. Sebab tu you nampak bila Q less than 1, according to equation, memang dia akan dapat lebih positif lah. Okay. Kalau sama, dia akan dapat sama. Maksudnya samalah, sama. Tapi kalau dia lebih more, or product lebih maksudnya dia dah habis dah, reaction dia dah consume kan. The reactant tu semua dah consume. So probably you akan dapat E cell less than E node cell. Clear? So we can simplify the equations. For T, kalau T ni lah under standard temperature ni, 298 ni, standard room temperature. So you can simplify like this equation. So please remember this equation. E cell is equal to E node cell minus 0.0592 volt divided by N is the number of electrons involved in the reaction. Yang ni pun student selalu silap. Dia tak take note on this lah kan. Dia tak tahu apa, kadang satu lah. Kalau dua lah, and then log Q adalah product over reactant, the concentration. Okay. Ini ada inilah contoh soalan dia. Okay, so in the test of a new electrodes, a chemist construct a voltage cell consists of a zinc and the H2 under the following conditions. Okay, kita ada zinc. So as you can see here, dia punya concentration and the pressure semua is not non-standard. Okay, so it's non-standard. Okay, so bila non-standard kita kena pakai Nernst equation. We need to apply this Nernst equation to determine the E cell. Okay, so before we use this, we must know the E node cell. So E node cell kena tahu, dan juga Q pun kita kena tahu. Okay, so again sama jugalah, you need to find the E node cell. You can identify mana anode, mana oxidize, mana reduce according to the E node from the table kan given. And then you can find Q using this concentration. Okay, cuma this soalan ni dia berbeza sikit sebab dia ada gas. So Q ni I think this soalan kot kan. So Q ni kalau gas yang ni lah kena kira lah kan berapa ni. Kalau ini PV equals to NRT, remember that you have learned about the PV equals to NRT. Why? Because we need to find the concentration. Okay, sebab kat sini dia ada gas kan, hydrogen. So we need to find the concentration. NV is we can find the concentration. Is mole per volume kan, mole, number of mole divided by volume, kita akan dapat the concentrations. Okay, so when we plug in the value, so we can find the Q. Okay, we find the Q, right? And then solving for E cell using the formula Nernst equations. Okay, masukkan value Q and then E node cell, dan kita akan dapat the value lah. Okay, dia tinggi ke lebih rendah tadi, kita tengok tadi dia lebih tinggi. Okay, so dia lebih tinggi. Okay, dia E cell tu lebih tinggi daripada standard ni. So yang ni simplified version lah to understand lah. Kalau Q less than 1, so dia punya E cell dia akan lebih daripada E not cell. So kalau dia lebih, dia akan kurang berbanding dengan E not cell. Macam as mentioned earlier kan, Q1 sebab dia dah produk dia dah tak ada dah. Bukan sorry, produk. Reactant tu dah tak ada dah untuk to do more work. Kalau kat sini Q less than 1, maksudnya the reactant tu ada banyak untuk do the work. Okay, yang ni inilah simplify tadi. Again, the summary of this product of reactant tadi. Okay, and then kita ada juga the effect of the concentrations. So that can exploit the cell potential. Dia boleh effect juga the cell that has the same half ratio in both cell compartments but with different concentration of electrolyte. Sebenarnya kalau ada different concentrations of electrolyte pun sebenarnya boleh juga berlaku ni lah. Okay, as long as the concentration of electrolyte are different, the cell potential is more than 0 and the cell can do work. So kita tengok contoh in this case kita ada satu from 0.1 molar of copper. This one is 1 molar of copper. Kita ada difference in concentration. So over time dia akan undergo oxidation reduction reactions. So until it reach the equilibrium. Okay, dia akan samalah. Okay, pun boleh juga berlaku. Okay. Okay, I think yang ni sama juga soalan tadi, we using the Nernst equation. I think please check later on. Okay, yang ni more on the applications lah. Kita tengok ada application of the batteries kan. Semua ada involve the oxidation and the reduction reaction. Okay, kita ada fuel cell. Okay, corrosion, rusting of iron. All of these are the example of the electrolytic reactions. Okay, yang ni sign tadi tu lah. Kan ada tengok juga simplify tadi, voltage more than 0, delta G is less than 0. Okay, and then the signs kan. Alright, so okay, and then I think this one we continue lah next week boleh kita ada sikit lagi for this topic. So I think kita akan continue with this stoichiometry of electrolysis lah. Okay, alright, it's very simple sebenarnya to calculate the amount of the mass electrons yang we call precipitate. Kalau kita tengok dalam electrolytic reactions kan ada yang diffuse atau yang dissolve dan ada juga yang form a solid kan. From there we can calculate berapa charge ataupun berapa voltage yang diperlukan untuk precipitate a certain amount of amalgam kan. Okay, so I think we continue lah. So this topic we have next week. We can continue next week for this topic. Alright, so do you have any question? Oh, kita dah habis. Sorry. Kita habiskan je lah stoichiometry ni. Saya ingatkan jauh lagi dia punya ni. Are you okay?
Yes, Doktor. Okay, boleh?
Boleh Doktor, boleh.
Doktor boleh.
Saya ingat banyak lagi dia punya stoichiometry ni. Dia very simple lah sebenarnya. It based on the Faraday's laws of electrolysis state that the amount of substance produced at each electrode is directly proportional to the quantity of charge flowing through the cell. Okay, so the amount of substance produced, ni dia punya proportionality equation dia lah. So kalau lagi banyak charge yang flow ni, lagi banyak substance yang akan produce at each electrode. Okay, so the current flowing through this cell is amount of charge per unit time. So you need to understand lah, charge is equals to current times time ataupun charge over time kan, charge over time. So you akan dapat the current kan. ataupun di punya air kan, amperes ataupun current tu. Charge per seconds. Charge per second. Okay. Saya suka lagi charge per second. Yang ni lah. So the relation is like this. So we have the mass of the substance oxidize or reduce. Sama ada dia reduce atau ni, dia sama je. And from there we need to mass macam nak convert kepada mole. We divided by the molar mass, so ia akan dapat number of mole lah. Number of mole yang participate in the redox reactions. And then we need to balance half reactions. Okay, why? To make sure that we have a correct mole of the electrons. Okay, you need to understand that ini different any mole of substance, any mole of electrons. Okay, sometimes mole of electrons ni tak sama dengan mole of ni. So the one yang kita consider adalah mole of electrons. Okay, so jangan confuse this one. So when we get the mole of electrons, baru we times with the Faraday constants. Okay, Faraday constant, the unit is the coulomb per mole electrons. Okay, mole electrons. So bila mole electrons time Faraday, kita akan dapat charge. So charge, tadi back to this equation, charge over times is equals to current. Okay, faham tak? Faham tak the flow dia? Ami, okay Ami. Ami.
Okay, Doktor. Okay.
Okay, so faham anyone else? Yang lain okay tak? Clear tak di punya flow ni? You can go back and forth lah. Kalau kita ada current, for example current, kita macam mana nak cari charge? Kita times darab dengan masa times, kita akan dapat charge. From charge ni kita boleh divided by Faraday ni, kita akan dapat mole, dan kita boleh calculate mass. So the keyword is the most important, as I have been as much as highlight adalah please look at the unit. So if you look at the units, so insyaAllah you will get the correct answers. Kalau you nak find mass, you need to make sure that you will get the gram lah. Kalau nak cari current, make sure you have the amperes unit. Okay, for example, this equation. A technician placed a faucet with a 0.86 gram of chromium metal by electrolysis of aqueous chromium sulfate. If 12.5 minutes is allowed for plating, what current is needed? So yang ni berbalik pada tadilah. So dia tanya what is current is needed. Dia bagi mass. So yang ni soalan dia straightforward using this flow lah. Okay, so kita ada mass. So mass yang nak cari mole divided by molar mass. Okay, good. So kita akan dapat mole of chromium. So remember that we are not looking for the mole of this substance, tapi kita nak cari mole of electrons yang apa, itu yang penting Yang ni yang you kena buat darab silang, you kena make sure lah. Okay. Bila dah dapat mole of electron transfer, kita akan times with the 9, this one adalah Faraday, kita akan dapat charge and then current. Okay, so yang ni dia punya equation dia lah. So that's why saya kata you need to look at the unit. Okay, please look at the unit. So gram kita nak dapat mole kan, so divided by molar mass, mole per gram, so you boleh cancel out gram, so akan dapat mole. So this one adalah mole of chromium, tapi kita nak mole of electrons transfer. Let me highlight again. Okay, so that's why you kena tahu juga dia punya redox reaction dia macam mana. So in this case chromium dia ada Cr3 plus 3 electron to produce chromium solid, betul? So dia ada for 1 mole of chromium ni dia equivalent to 3 mole of electrons. Okay, so 1 mole, saya tulis yang ni sebab selalu student buat silap. Dia equivalent to 3 mole of electron. So kalau kat sini for example lah, mole yang ni bukan 1 mole kan. So yang ni kalau 0.86 divided by 52 berapa? Berapa?
Zero point zero three six.
0.016 kan?
17.
0.0 okay, 0.17 boleh lah. 0.017 mole of chromium. Maksudnya berapa mole of electrons? Berapa? Jawapan dah ada dah kat sini, tapi saya nak awak faham lah. Kalau 1 mole is equivalent to 3, semula 0.01 bersamaan dengan darat silang lah kan. Darat silang times 3, you akan dapat 0. Ini 0.05 lah. Betul
Yeah.
Okay, so the moment you get the mole electron, baru you times with the Faraday constant. Yang ni mole dia adalah charge per mole of electrons kan. So you boleh cancel out more electrons, you akan dapat charge. So charge macam mana nak find current? Come on. Charge, how do we find current?
Divide by time.
Okay, divide by time. What is the time tadi tu berapa? 5.5 minit. Yang ni please don't use the minute lah kan. Maksudnya you kena convert to second. Okay. To the SI unit. So charge divided by seconds, you akan dapat current. So 4.8 times 10 to the power of 3 divided by 12.5 minute, which is equals to how many seconds? Darat lah. Darat 60. You akan dapat seconds. Please change first to seconds, then you akan dapat the correct answer, which is 6.4 ampere. So meaning in these reactions, they use 6.4 current. Okay, current yang digunakan adalah for 12.5 minit dia will get this amount of chromium. Okay, chromium yang melekat pada apa-apalah sudu ke apa kan. Okay, dia nak sadurkan dengan chromium. So dalam masa 12.5 minit, okay, with the total amount of current of 6.4 ni, using 6.4 ampere ni, so dia akan dapat 0.86 gram of chromium. Okay, faham So sama juga soalan ni, kalau dia give the current, berapa mass yang kita dapat. So kita just play around with the units. Okay. Alright, so that's all. Do you have any questions? Ada soalan? Just cut. Just stop.